Hi, I'm Corbett Lunsford. I'm the Executive Director of the Illinois Association of Energy Raters and Home Performance Professionals. It's a Midwestern trade association that also provides quality assurance over members. And for those of you who know what it is, it's a ResNet rating provider. So we essentially are the association in the Midwest that is a nonprofit that's a go-to source for information on new homes, gut rehabs, how to make existing homes more energy efficient and more high performance. And we're going to talk about the difference between those two in this presentation. So I'm going to talk today about just taking advantage of HERS raters, what they can do, and then the third-party performance testing that you get as a part of that. So first of all, we call it home performance, not energy auditing or energy efficiency consulting, because the home is a system. That's the central tenet of this industry. And we analyze it in 4 different aspects. The first is heat flow. Everyone thinks they get heat flow. Hardly anybody actually understands heat flow. If you ask a homeowner today, if you are a homeowner yourself, which I assume you are, what you think you need in your house in order to make it more high performance or more energy efficient, you would probably first think of new windows and more insulation. And that tells me that you're at least thinking about heat flow. So it's on your radar, and that's good, but there's math involved with that, and I'm going to show you a little bit about how that works. Airflow and pressure is the second aspect, and this actually hardly anybody understands truly. Airflow and pressure are 2 sides of the same coin, and so you want to really look at this because air leakage is actually the single biggest opportunity for improvement in any home. And hardly anyone knows that because there's no lobby involved in that. There's no giant manufacturer that's making products for this. There's no advertising for it or anything like that. It's very unsexy, to quote President Obama. So moisture is the third thing on the list, and as you can see, these things are getting bigger. That's because they're more important. Moisture is way more important to control than heat flow. If your house starts falling down around you or develops mold, that's a much bigger deal than you paying a little extra on your energy bills. And the last thing is air quality. Air quality, obviously, if your kids have allergies or asthma, or they're going to the hospital more often than they need to, or you get mold problems in your house, that's generally kind of a freak out situation. The worst case scenario in this realm is the families that you read about in the paper who don't wake up in the morning because they accidentally hit the auto start on their car overnight, and it ran carbon monoxide into the garage, which got pulled into the house, and everyone in the family is dead. That happens. So we want to really avoid any air quality issues because obviously if you're sick or if you're dying, it defeats the whole purpose of trying to fix homes anyway. Okay, so here is where energy efficiency ends, after heat flow and airflow. Now if you remember, they're increasing order of importance. These are the 2 least important things on my list, are the energy efficiency portion of this. Moisture and air quality, way more important than stupid energy bills. So yes, we care about saving energy. It's a personal financial issue. It's also a national security issue. Saving energy is great. I love it. It happens to be the only way we can actually quantify how awesome we are making the homes, but the goal is not energy efficiency. The goal is control. So if you want the definition of what a high-performance home is, here it is. If you control all 4 of those things, then you will get a high-performance home out of that. Now the problem is going to start to be that the new codes, which you can see here, the 2012 IECC, which we're actually adopting in Illinois, that's one of the reasons that our association is very important at this juncture, is that the 2012 is going to take us toward this high performance goal, but if people aren't focusing on all 4 aspects and you just focus on the heat flow by super insulating or on airflow by air sealing, and you're not fixing the moisture and the air quality or paying attention to controlling them, then we start to have real problems. And here is why. So I'm going to give you 3 quizzes during this, and obviously you can't interact since this is just a video, but a higher performance home is more blank than an average home. Dangerous or safe? Most people probably are going to say safe, but in fact, dangerous is the correct answer. Think about a high-performance home as a Ferrari and a normal average home. And average means not that great. More problems generally, higher bills, things like that. The average home is going to be a lot more flexible because there's a lot more just kind of uncontrolled stuff happening in there. So that uncontrolledness is all kind of balancing itself out, and there are problems that develop, but it's a lot looser system. Once you start making a high-performance home like a Ferrari rather than a Corolla, you need to take it to the shop once a month or once every 3 months without fail. You need to use special tires on it. You need to be educated about how to rev up, what RPMs it needs, etc., etc. So it really takes a lot more homeowner education, a lot more contractor education on the maintenance side of these homes in order to actually have these systems work, because you are getting the highest quality thing. You're getting a high performance home. That means a lot, and I'm going to talk about what it means. But in order to have that, there's more responsibility. So, if you are a builder, if you're an architect, if you're an inspector, if you're a code official, if you're anybody who's involved in the building industry, if you start paying attention to this, will help prevent thousands of totally avoidable illnesses, callbacks, lawsuits. That is the number one benefit. You get to sleep better at night knowing that, man, you did a kick-ass job today. And pardon my French, I have a little bit of I'm trying to be entertaining. So, the totally avoidable part is important. This does not have to happen, and what I'm going to predict right now is that we will have, over the next number of years, a backlash against high performance, because people will say, high performance homes kill people, they make people sick. It's absolutely not true. People who aren't paying attention make people sick and kill people. Absolutely. And those people will probably be being sued, have more callbacks, and go out of business as a result. The people who pay attention to this will really feel the benefits, have clients who are happy, who are delighted with their homes. They stay, they don't travel quite as much because their home is like a vacation. And your clients will be thanking you for this. Now, if you're a homeowner, the benefit is exactly the same. You, yourself, your own totally avoidable callbacks, warranty issues with your new home, warranty issues with contractor work, all that stuff gets fixed because what we're talking about is proof. Okay, now, prescriptive compliance. This is if you're a code official, you understand how this works, or if you're an architect. You can start to comply by following a recipe for building a new home. The new home recipe for prescriptive compliance basically goes something like this. If you want a home, just like if you want chocolate chip cookies, you use this much flour, this much chocolate chip cookies, this much oil, this much sugar, and you mix it together and you bake it on this setting, and there you go. Now, if you start to say, you know what, I'd really like to have raisins in this, or I'd like to have M&Ms instead of chocolate chips, then you start messing with the recipe. Maybe you're at a different elevation. Maybe your oven is different. Maybe you've got, you want to be able to use a microwave instead because you just can't follow rules. I have a little bit of a problem with that myself. So if you want to start playing with the system, bringing your personality out, being more customized, you can't use prescriptive compliance. And if we really believe that the home is a system, we all say that all the time, then there is no way that prescriptive compliance works, ever. Because you can't prescribe these things. You have to make sure that they're actually being installed properly. That takes oversight on every step of the process. And that's what the HERS raters do. So we're talking about HERS raters and also BPI certified professionals here, but specifically HERS raters on new construction, on gut rehab. So if you're doing a massive remodel of your home, you're going to want a HERS rater. They get involved in the planning stage on the energy modeling side. They get involved in recommendations, right, at that point. Then they go in and at rough-in, which is in the middle of the construction process, they do inspections. And then they make more recommendations. Then they come back when the house is all done and they test all of the systems that are installed, the HVAC system, the air sealing in the envelope, the insulation, things like that, the ventilation system. And they're going to test it and make sure that it does actually what it was installed to do. Then they're going to make some more recommendations. You can see that this is actually really heavy on the recommendation side. That's because a HERS rater does not rate. A HERS rater helps you to make your project better all the time. My favorite clients are the builders who come to me and say, I want to be a better builder. I love hearing that. So all of us can be doing better. We need to be, getting trained more. We need to be reading, and we need to be involved in the conversation. And if you're a homeowner, you can really take advantage of professionals who pay attention to this degree of detail. These are the kind of people you want to be working with. So a HERS rating is from 0 to 100 generally. 100 is a house that's built to code. You want your house to be closer to 0. 0 would be a net zero energy house. That would be the most awesome house you could have. You can't go negative. You can go over 100. My existing home clients are generally over 100 when they start out. Energy Star Homes verification, right? So Energy Star Homes is a certification you can get from the federal government. And then Builder Tax Credit verification. The Builder Tax Credit has been a historic since 2005, $1,000, $2,000 back for building a home that's better. Okay, so at the planning stage, when you get into energy modeling is a computer simulation of a home, the way that it's planned to be built. Put it in, find out what it does, how we could maybe make it better, how it would perform better. Now, the assembly U value and the performance-based, those are both kind of code terms. So if you're a code official, you'll understand how that works, if you're an architect as well. Okay, then in the middle of construction, we go and we do rough-in inspections. It's a carpentry term. It means that all the framing is basically in, but there's no finishing details on there. So the drywall is off, and you can see every bit of the inside of the walls. Now, the secret that hardly anybody actually understands is that even when the drywall goes up, we could still find out what's going on in those walls. There is no way to hide bad work nowadays. So if you suspect you're getting bad work, then you should hire someone who can do diagnostics to take care of finding out whether the work was bad or whether the work was good. You can't hide anything anymore. There's a test for everything. So, water management inspections, thermal enclosure system inspections, which is where the air sealing and the insulation layers align. It's the jacket for the house. The HVAC installation, testing the ductwork, testing the equipment, making sure that everything is installed properly and looks like it's ready to go before we start closing things in and making it difficult to fix. Okay, Energy Star version 3 is a new program that just got rolled out. Actually, it's being rolled out as I record this tomorrow, officially. You need to be stealing these and using them. If you're a builder, if you're an insulation installer, use the thermal enclosure system checklist. It's free. Steal it. Use it on every single job to make sure that your employees are doing their job and that they're earning the money that you're paying them. If you're a code official, feel free to check them out. Steal them for your visual inspections. And you can see the checklist link there at the bottom, so go ahead and feel free to visit that. And then performance testing. This is the key to our entire industry. The difference between a house that's built high performance and a house that's built that says it's green or energy efficient or whatever is that a high performance home actually has proof that it is high performing. And proof is this performance testing. It's scientific testing, also called diagnostics, that shows for a fact that the house is better than the other houses on the block. Just because you say a house is green or a house is energy efficient or a house is sustainable or anything like that doesn't mean anything. Everyone says that. It's marketing. The difference is proof. So the only way to get the proof is to do envelope testing, blower door testing, infrared imaging, zonal pressure testing, which I'm going to explain in a minute. And on the HVAC side, it actually testing the ducts. Just because they've got tape on them doesn't mean it actually does anything. In fact, in most cases it doesn't. That needs to be done in the rough-in stage, in the middle of construction, so that you can actually fix problems when they develop. And I'm telling you, I test these systems all the time, and I know for a fact that almost every system needs work before you close it in with drywall and make it impossible to get to. Because once you install a duct system, it's never going to be installed again. Mechanical ventilation. Just because somebody says, oh, this house is getting 100 CFM of fresh air ventilation every day, doesn't mean it's actually happening. You need to test it, make sure that you're getting the fresh air in there, because it might be that somebody forgot to take the tape out of the fan, or to, turn it on, or to clean the filter or something like that. And then balancing, really important also. So here's your second quiz. Why are we doing this? The goal of performance testing is either you want to obsess over stupid details that don't mean anything except a bunch of numbers. B, piss off the trades. I want my framing guy to be mad at me. I want my HVAC guy to be mad at me. Or C, demonstrate whether you did the job right or not. That is the correct answer, obviously. So the whole key to this is we will know whether the job got done right or not. And people who are really smart about this, the contractors and the builders and the architects and everybody who is good at this job, are testing themselves and learning from their mistakes and fixing them before they leave the house. The bad contractors don't test themselves, and they just wait for somebody else like me or like a HERS rater to come into their client's house and test it and find out, oh, you know what, that guy's no good, don't ever hire him again. And then they go on to Angie's List, they file a complaint against them, blah, blah, blah. All this stuff can be totally fixed if we pay attention while we are actually doing the work. Okay, so in the 2012 IECC, there are numbers. This number for duct leakage testing is 403.2.2. What it says is you always have to do duct leakage testing unless the duct system and the air handler are all located totally within the envelope. Now you can see in my picture here that this duct system and air handler are inside of a room that has exterior doors on it, but the room is technically inside the garage. So is it inside the building envelope or is it not? You should always be testing, and I do this test all the time, even if a duct run is inside of an interior wall, but that interior wall has a junction with a floor cavity or with a ceiling cavity or with the attic. That will generally leak to outside, and that's really, really important. So if you have a duct system that's completely visible, you can see every bit of the ductwork from the living space, then I say it's fine, you don't have to test it. But it still needs to be sealed with mastic. Now, the goal here is less than 4 CFM of total leakage per 100 square foot of area served, and that's technical. We can get into that later. Feel free to get in touch with us through our website, ilenergyraters.org. Here is the form. The ASTM and ANSI standards for testing in general are pretty complicated. Most people, when they're doing a duct system tightness testing, they just tell you what the CFM is, which is cubic feet per minute. That doesn't really make any sense. You want to know a whole bunch more stuff about the scenario that this test was conducted under. This form that's available on our website is built to run that scenario for you so that everyone who sees this data knows exactly what kind of day that was that it was run. Envelope testing, this is a blower door test. This is 402.4.1.2. You can see that this is really crazy to try and navigate this book, but it's set up in a kind of a reasonable way once you start studying it. This is a third-party blower door test. So what you want to know is how leaky is the house. Okay, now what is the blower door test? A lot of people say, oh, the blower door moves air from inside the house to outside the house, and then it depressurizes the house to 50 pascals, blah, blah, blah. Now, if you're a homeowner and you're listening to me say that, you probably start feeling like, ugh, this guy's talking about mumbo jumbo. You're absolutely right. It's total mumbo jumbo. We don't talk about that. What we want to talk about instead is, at its heart, the blower door and all diagnostic tools are your opportunity to prove that your house is better than the other houses on your block. That's what it is. And if you're a contractor, it's your chance to prove that you do better work than your competition. That's all it is. It's a tool to demonstrate that you rock. Okay, so the goal there at the bottom, that's technical. Don't worry about it. Again, you can contact us if you have a question. Again, we have a form that's specifically set up so that you have all the information. Transparency is really important. And so we want to make sure that the technical data is available. That being said, we try not to, in general in our field, give too much technical information because technical information is bad for actual education. That's kind of a weird contradiction, but it's true. Okay, so zonal pressure testing. This is one of the most underutilized tests. That's one of the reasons why it's my favorite, because I'm the only one who's doing this in many of the houses that I go into. So what you want to know is, where exactly is the envelope? And again, the envelope is the jacket for the house. It's where the air flow is stopped and the heat flow is stopped. It's insulation and air sealing. And is it effective? Now, just because you have insulation in the ceiling of a crawl space or on the floor of an attic doesn't mean that where the insulation is where the jacket is, because the secret is air leakage always beats insulation. So we want to use this test to not just verify that the insulation is in the right place, but find out if it's not in the right place. That way you can relocate it. Okay, so here's how it works. First, you need to know about manometers. This is a manometer. This is a line drawing. It's not an actual one. It has an input tap and a reference tap on two separate channels, left channel, right channel, channel A, channel B. Okay, they both have a differential that they measure. They measure the pressure in something with reference to something else. There's another video on our YouTube channel that goes through this. So the name of the test tells you what goes in the input tap. In case you are a professional, you're using a manometer, that's a real cool trick to be able to use. And the goal is, essentially, every room in your house needs to be either totally part of the house or totally not part of the house. And I'm talking also about not just your master bedroom, but the attic, the garage, the crawl space, the basement, things like that. They need to be either totally inside or totally outside. There is no gray area. Okay, so we depressurize the house, right? And we get to this magical number that's negative 50 pascals. It's just a technical thing. It means that we're depressurizing the house with reference to outside. We test the bedroom on the left. The bedroom on the left is 3/50ths connected to outside. That's about 7%. Okay, so that bedroom has a 7% connection with outdoors. The bedroom on the right has a connection of 10/50ths, which is about 20%. That's a big jump. In fact, the bedroom on the right seems to be a little smaller than the bedroom on the left. Remember, we're in bird's eye view. We're looking down on the house at this point. We test the garage, which is my big suspicion now, because the only difference between the bedroom on the right and the bedroom on the left is that the bedroom on the right is connected with this attached garage over here. The garage test says 29/50ths outside. We want every room to be either 50 or 0. This garage is about halfway connected to outside, which means it's also halfway connected to inside. This is a garage where if you parked a car that was running, even if the garage door is open, everyone in the morning would be dead. That is terrible. So the goal here, especially if this is a new home, and I run this test on new homes all the time, and I find this all the time, is to air seal the garage so that it is absolutely not ever part of the house. And then air seal the perimeter, the exterior perimeter of the second bedroom. The bedroom on the left is still 3 because we didn't work on it. Bedroom on the right went from 10 to 2. That's really good. That's a lot closer to 0. And the garage moved a lot closer to 50, which is excellent. Okay, so pressure pan testing. This is another test that we can use to diagnose what's going on behind the drywall. So you don't have to guess what's going on inside your house anymore. You can know always. Zonal pressure testing is done on rooms that have doors. When you have a zone that doesn't have a door, like an interior wall or a recessed light or a duct, something like that, then you need a pressure pan. This is like a $75 item. It's not that hard to get a hold of. So we use it to localize where the duct leaks are, because if you did a duct leakage test, it'll tell you how much they leak but not where. This is how you find out where exactly the problems that need to be fixed are. You can start diagnosing other things that are going on inside the wall and ceiling assemblies. Okay, so when you have a HERS rater, not all HERS raters are created equal, and in fact, not all HERS raters are actually legit. You need to know that they're with what's called a ResNet accredited rating provider, which is an umbrella organization, which is what the IAER is. If they're not under one of those umbrella organizations, they're a rogue rater, and you should not believe anything that they say. So in the REM building file reports, I have a special protocol that I use to evaluate the areas and the components, make sure that everything mathematically makes sense, because this is actually, when we build the computer simulation, it's not a visual graphical representation like a 3D model. It's just a bunch of numbers. So you have to start really looking at the numbers and making sure that they make sense. Looking at the equipment, making sure that the performance testing projections, when we're building a planned house that is not actually existing yet, you have to kind of guess what you're going to get with the performance testing. And a good HERS rater will be able to do that for you. And then on the performance testing side, no one who says that they ran your duct leakage test and it was 0 for total duct leakage, that's not real. They're lying to you. Also, the blower door numbers should be always given to you in CFM, not in air changes per hour. And this is a little bit technical, and I apologize for that, but I just want to make sure that anybody knows that there are ways to quality assure that your raters or your BPI certified professionals are telling you stuff that's actually real. They're generally always trustworthy, but sometimes you get people that are trying to pass off the same quality of work, but they're not actually doing that quality. So we make sure at the IAER that never happens, and we do that in a number of different ways I'll describe in a minute. HERS raters earn their stripes by A, filling out a form and paying a fee, bribing the governor of Illinois, in Illinois where we are, or going through a rigorous training and testing situation. And in our state, for the Illinois Association, we have what I think is the only really well-structured mentorship program in the entire country. And I'm happy to talk with people about that if you want to contact us through our website. Again, it's ilenergyraters.org. Now, ResNet is an ANSI standards development organization. That's really important. It's going to start to be cited in the IECC 2012, or excuse me, in the IECC 2015. It'll probably be in there straight out. You need to hire a HERS rater for this. Okay, now obviously the answer is this. HERS raters are for real. These are people that you can trust. It's not somebody who went down to the county seat and filled out a form and paid $50 and got an HVAC license or a builder's license. This is a real thing, and there's quality assurance involved in every step of the way. So you can feel confident, especially with somebody who's with the Illinois Association of Energy Raters, because the IAER performs 100% REM rate QA. So when they send an energy model to us to make sure that everything is good, I literally look through every single file that comes in. The rule is that you have to look through at least 1 out of 10. I don't think that's right. That makes no sense to me. That sounds stupid. So what we do is we literally, every step of the way, we're making sure that there's a double layer of reasonable assessment and analysis on everything that happens. That's why you can really start to trust your HERS raters and your BPI certified professionals that are with the IAER. We also do 1% field inspection and performance testing, which is the ResNet standardized level. That means that 1 out of every 100 homes that a HERS rater does, we literally send somebody who's more highly qualified out to retest that place and make sure that it actually performs the way they said it does. For the IAER, we actually have continuing education. We have a monthly webinar trainings. We've got annual meetings. We've got all kinds of mentorship perks and things like that. So we make sure that everybody really knows what they're talking about. And then we are quality assured in turn by Resonant, which is the umbrella organization over us. If you are looking for a certified rater in Illinois, you can find them on our website at ilenergyraters.org by searching geographically in your zip code there. And they'll be listed by their location and their certifications, things like that. That if somebody's on this list, then they are certified. BPI Certification would be located here at bpi.org. Now, if somebody's not on this list, it doesn't necessarily mean they're not certified, because BPI sometimes has a hard time keeping up with this list, but if they are on this list, you can be sure that they actually are certified. So there you go. Great, thank you very much for your time, and I hope that this has kind of clarified what a HERS rater and a third-party verifier can do for you. Please feel free to contact us through our website. Again, it's ilenergyraters.org, and I'm Corbett Lunsford. Thanks very much.